Today's lesson is on the quadratic formula, another method to solving quadratic equations that is usually my go-to if an equation doesn't factor quickly and easily. But let's start with by practicing completing the square one more time. So we've got this equation, 3x squared plus 54x plus 156. In my experience, a good first step is always make sure it equals 0. So let's get rid of that 12. I'll do that by subtracting it from both sides. So we end up with 3x squared plus 54x plus 144 is equal to 0. Now, whenever we've tried to solve a quadratic equation in the past, it hasn't really had any number in front of x squared other than 1. And if it did, it really just made factoring a pain. So I'm going to try to get rid of it. Let's divide everything by 3. So we'll end up with x squared plus 18x plus 48 equals 0. We really lucked out here that everything was divisible by 3. From here, we can either try to factor. We can look for a pair of numbers that multiply to make 48, that add to make 18. Or we can jump straight into completing the square. I'm going to jump straight into completing the square because I don't think anything multiplies to make 48 that adds to make 18. So if this is going to be a complete square, I should have a plus 81. So I'm going to take advantage of that little trick of algebra. If I add 81 and subtract 81, nothing really changes. So that gives me x squared plus 18x plus 81, because that's my complete square. And then minus 33 just tells me how far off I was. We were 33 below the complete square. The left side factors, x plus 9 squared. And then we'll solve by taking square roots. X plus 9 squared. Take the square root. X plus 9 is equal to plus or minus the square root of 33. So x is equal to negative 9 plus or minus the square root of 33. Now, because we got that square root of 33 in our answer, that tells us that it wouldn't have factored in the first place, so it's good that we didn't even try. But we really had to rely on a method of solving that's really just memorization of a factor of steps and a weird trick of algebra. Instead, we could use the quadratic formula. The quadratic formula is really a catch-all. This equation will solve any quadratic of the form ax squared plus bx plus c equals 0. So if we have a quadratic equation that is set equal to 0, this formula will always give us the solutions. If it factors, we'd end up with the same answers. If you solve it by graphing, you'll end up with the same answer. If you solve it by completing the square, you'll end up with the same answer. So let's see it in action. A is always the coefficient in front of x squared, b is always the coefficient in front of x, and c is always the term at the end. So in this equation, a is 1, that's what's in front of x squared, b is 3, and c is negative 4. Now, you might be able to go ahead and already solve this by factoring. By factoring, this takes 2 steps, right? 4 and negative 1 multiply together to make negative 4, that add together to make 3. And then by splitting it up, you can get x equals negative 4, x equals 1. Now that'll just solve for as a good way to check our work, make sure we've done the quadratic formula correctly. So I'm going to take this formula, copy and paste, and we're just going to plug in, right? For each b goes a 3. For each a goes a 1. And for each c goes a negative 4 for the 1c. And from here, this is why I like this method so much. There's no trick of the algebra. There's no extra steps to memorize. It's just simplify as much as it simplifies. So we have x equals negative 3 plus or minus 3 squared is 9. 4 times 1 times negative 4 is plus 16. And then our denominator is 2 times 1, which is 2. 9 plus 16 is 25. The square root of 25 is 5. And here it's all just whole numbers. We can do this work kind of by hand. We just need to make sure we split it up and get both answers. Negative 3 plus 5 over 2 and negative 3 minus 5 over 2. Negative 3 plus 5 is 2. 2 divided by 2 is 1. Negative 3 minus 5 is negative 8, and negative 8 over 2 is negative 4. Check it out, same two answers we got by factoring. So if a quadratic equation factors, by all means factor. After factoring, this is my go-to if I want to solve it algebraically. So let's check out another one. Here we've got 9x squared plus 12x plus 4. Unfortunately, there's no common factor here that I can reduce everything by. If there was, I would certainly divide it off first. So let's instead identify our A, which is 9, our B, which is 12, and our C, which is 4. Now this one does factor, and it does kind of nicely. I'm not going to attempt it, though. I've really found that just whenever A is greater than 1, factoring might not be the easiest path, so I'm not even going to chance it. Let's just take our quadratic formula and plug it in. For each B goes to 12. For each A goes to 9. And for the C goes to 4. And we reduce as much as possible. Let's see. 12 squared is 144. 4 times 9 is 36 times 4 is 144 over 18. A 144 is 0. So I really don't have to worry about that. That's just negative 12 over 18, which reduces by 6 to be negative 2 over 3. This one just has one answer. Sometimes that happens. Let's try one more. X squared plus 4x equals negative 5. Now I did mention at the very beginning, it has to equal 0. That is a must. For the quadratic formula to work, just like factoring, we have to make sure that our equation is equal to 0. So let's get that 5 over there. X squared plus 4x plus 5 equals 0. Now we can do this. A is 1, B is 4, C is 5. Take our equation, plug it in, or plug everything in. For each B goes a 4. For each A goes a 1. And for C goes a 5. Simplify as much as possible. So we have negative 4 plus or minus the square root of 4 squared is 16. 4 times 1 times 5 is 20. All over 2. 16 minus 20 is negative 4. So that's negative 4 plus or minus the square root of negative 4 over 2. And, well, it looks like we're going to have an imaginary number in our answer. Negative 4 plus or minus the square root of 4 is 2. So the square root of negative 4 is 2i all over 2. And this fraction then reduces to negative 2 plus or minus I. So we still have two answers. It's just now it's complex. So we've seen 3 different equations and each have a different kind of answer set. We had one where there was 2 real answers. We had one that had one real answer, and one that had 2 complex answers. So the difference was what we were taking the square root of. Here, we took the square root of a whole number, or of a positive number, and got 5. So that's where our 2 real answers came from. Here, we ended up taking the square root of 0. And when you add and subtract 0, that doesn't really change anything. So we just ended up with 1 answer. And here we ended up taking the square root of a negative, which gave us an imaginary number, which gave us our complex solutions. So the discriminant is just the part that's under the square root. B squared minus 4ac. If all we need to know is what kind of answers we should have, the discriminant will tell us. If we end up taking the square root of a positive number, we will have 2 real solutions. If we end up taking the square root of 0, we have 1 real solution. And if we end up taking the square root of a negative, we will have 2 complex solutions. Now, to be clear, this will not tell us what the answers are, just what they look like, the discriminant. All right, thank you so much. Please let me know if you have any issues.